Hello everyone, welcome back to my channel Cloud and Coffee with Navneet. In our last video, we have covered how to calculate the storage requirement for the OpenSearch. Today we are taking the step next and diving into the Shards configurations. This is a crucial step for optimizing your OpenSearch cluster, similar to the storage requirement. So let's explore how you can set up your shard effectively and why it is important for efficient shard distributions and cluster for your cluster health. Right, so let's get started. So first, let's understand, shard configuration in OpenSearch Service. So when you're working with an OpenSearch Service, understanding how shards are configured is essential for your ensuring both performance and scalability. So let's start with the basics. So in OpenSearch Service, each index is divided into 5 primary shards and 1 replica shard. So it's totaling 10 shards. However, in open source OpenSearch, the default is simpler. It's just with the 1 primary shards and 1 replica shard. So it's total 2 shards per indexes. So remember, when primary shards contain your actual data, so while replica shards act as a backup, ensuring you are having this fault tolerance, high availability in case of the node failure. So here are the key considerations. So when you work with the sharding, just ensure the number of primary shards must be decided well before you can start indexing data. And the reason being, because changing the number of primary shards after indexing being done is not straightforward. So it requires re-indexing the data, which can be time consuming and costly too. So making by making the informed decision around the sharding will help you to ensure you will be not able to run into any performance issue down the line. So other guideline around the shards is, so after deciding, like let's say once you have decided how many number of shards, and I will be showcasing how you can able to calculate down the line. So after deciding how many number of shards, the next critical step is determining the optimal size of the shards, right? So why it is important? Again, because each size of the each shards directly affect how your cluster performance and respond to your workload. So if you end up creating small shards, it can be overwhelm your hardware resources, causing high CPU or memory usage. If you are having too big of shards, that can be complicate into the recovery. Let's say if there are any failure or anything, so recovering the very huge amount of shards will take a lot of time, and I have seen out of memory issue as well. So the key to find the balance that align to your workload is very specific. So there are some guidance. So if you are having the search related workload, or if you are having latency sensitive workload, keeping the shard size between 10 to 30 GB is an optimal. But if you are having the right heavy workload like log analytics, you should aiming for around 30 to 50 GB of the shard size, right? So just ensure you will be having the right size. Do not want it to have a too small of a shards, and you do not want it to have a too big of a shards, right? So that's there. So now let's go and understand how you're able to perform the calculation. So in this scenario, what we're looking to do is we are looking to see our growth is minimal over the time, and this is the formula which we're looking to use. So we are having the source data room of growth plus 1 plus indexing overhead divided by desired shard size, and that will give us the approx number of primary shards. So suppose you have a 66 GB of data and you said, hey, I'm not expecting any, or the growth will be minimal, so you decided to not to add too much of a storage, and then you will be having this you decided, okay, I'm going to have a 30 GB as an ideal size for my index, for my shards, right? And then you wanted to have because it's a right heavy workload. So now let's calculate how many shards you need for this setup. So as we know, this source data is 66 GB, and then room for growth is no minimal, so we are not adding any additional data there. Indexing overhead, which is kind of a 10%, which is represent as 1.1, right? And then you will be having the desired shard size, which we are calling it 30. So once I will be having everything being calculated, I will get to know this is like I need a 3 primary shards for me to have this 66 GB of data being stored, right? Let's go and explore next scenario. So in this scenario, we are looking to see we are expecting growth over the period of time. So if we are having this initial 66 GB of data, then we anticipate like, okay, we are going to have a 198 GB of a growth over the period of time. And we decided, again, it's a write heavy workload, so we decided our shard size is going to be 30 GB. Right, again, the formula will remain same. You will be having your source data plus room of growth multiplied by 1 plus indexing overhead, which is 10%, and then you will be having desired shard size, which gives us the approximate number of primary shards. So in this, we will be set like, okay, going to have a 66 GB plus 198 GB multiplied by 1.1, which is 10% of index overhead, divide by 30, which is our optimal size, and it gives us a 10 primary shards, right? So now you got an idea how you can able to calculate the shards. So once you're done calculating the shards, again, other consideration you're looking to do is how much heap memory you're looking to have, right? So you need to understand first the Java heap memory allocation is. So OpenSearch allocate, by default it's allocate 50% of the total instance memory to the Java heap by default. However, the heap size is capped at the maximum of 32 GB. Even the instance has more memory. For instance, if you are having an instance size which having the 64 GB of memory, the Java heap will be, as I said, like it's capped at 32 GB, and it's being only assigned to it will be only assigning 50% of it, so that's going to be 32 GB. Whereas if you have an instance of 8 GB, right, that it only allocate 50% of it, so the Java heap memory of 4 GB, right? So other allocations guideline is to maintain the performance and prevent resource bottleneck. You're not looking to have more than 25 shards per GB of a Jeep. You're not looking to have more than 25 shards per GB of Java heap size on a node. Example. So let's take an example. If you're using M5 large dot search instance which has 8 GB of memory, you will be assigning the Java heap size will be that is 50% of it, that is 4 GB. So recommended number of shards will be each node should not be go more than 100 shards, right? So as you're looking to have you're not looking to have more than 25 shards per GB of not looking to have a shards of 25 shards per GB of the heap. So if we are having this 4 GB of heap multiplied by 4 into 5, that comes as a 100 GB. So hopefully you got an idea how you can able to calculate the shards. So when you will be looking to calculate the shards, you can able to you're looking to calculate two part. One is definitely how much data you're looking to have initially, what will be the room of growth look like, and then index overhead, that is 10%. And then you will be having, like, based on what kind of a workload you will be looking to have, you will be having the optimal size of your shards, and then that will give you the number. Other is you're looking to do is ensuring like, okay, what instance type you're looking to have and how much memory you're looking to have, and then based on the heap size, Java heap size, you're not looking to have more than 25 shards per GB, right? So that will give you the total number of shards. With that, thank you for joining my video. Thank you for joining my YouTube channel, and hope you enjoy my content. If yes, please do like, subscribe, and share with your friends. Thank you. Bye.